Hello, my name is John McCartney, and this is my video for the IA 203 EECS application. So today I'm going to go over a few proof techniques, just a few of the basic techniques like the direct proof and the proof by contraposition, and then I'll go over a few definitions that are important to know, and then go over some examples so you can see how it works. Sound good? Cool. Alright. So typically we're going to be dealing with these proof techniques when we have a conditional statement, which is a premise followed by a conclusion. So for a direct proof, when you want to prove something like P implies Q, where P is your premise and Q is your conclusion, what you want to do is start with P, assume P is true, and then conclude that Q is true. And for proof by contraposition, we learned that the truth values for the conditional statement P implies Q is the same as the conditional statement not Q implies not P. So we can utilize that fact to prove some conditional statements that we might not be able to prove directly in a different way. So some important definitions that you're going to need to know is an odd number is an integer n. Integer n is odd if there exists a k, an integer k such that n equals 2k plus 1. And similarly, an integer n is even if there exists an integer k such that n is 2k. Alright, so some examples. We'll start with direct proofs. So let's see if we can prove that if n is odd, then n squared is odd. So this is of the form P implies Q, where P is n is odd and Q is n squared is odd. So for a direct proof, we start by assuming that P is true. So assume n is odd. Well, what does it mean for n to be odd? We define odd to be there is an integer k such that n is 2k plus 1. So we know there exists a k such that n equals 2k plus 1. And we want to know something about n squared. So let's see what that means about n squared. N squared is 2k plus 1 all squared. We can FOIL that out. That becomes 4k squared plus 4k plus 1. And you can see here that these two terms have a factor of 2 that we can pull out. So let's do that. So this is 2 times 2k squared plus 2k plus 1. So since we know that k is an integer, this means that also 2k squared plus 2k is an integer. So what this means is that n squared is 2 times some integer plus 1. So this means that n squared is also odd. And that's it. So we started with the fact that n is odd, and then we concluded that n squared is odd. So that's a direct proof. Now for proof by contraposition. If n is an integer and 3n plus 2 is odd, then n is odd. So there are definitely a few ways we could go about this. You might have to do a little bit of trial and error to see what might work and what might not, but I'm going to try contraposition. So in this conditional statement, we know that P is 3n plus 2 is odd, and Q is n is odd. So if we take not q, that means if n is even, so the negation of odd is even, this means then 3n plus 2 is even, which is not p. Okay, so let's assume not q is true. Well, from our definition, we know that this means there exists some k that's an integer such that n equals 2k. So what does this mean about 3n plus 2? 3n plus 2 is equal to 3 times the quantity 2k plus 2. And this is 6k plus 2. These have a common factor of 2. So this is equal to 2 times 3k plus 1. Now, since k is an integer, 3k plus 1 is definitely an integer. So 3n plus 2 is of the form 2 times some integer. So this means 3n plus 2 is even. And that concludes the proof. So we proved that if not q is true, then not p is true. And since this has the same truth values as p implies q, then we have also proved that if 3n plus 2 is odd, then n is odd. Thank you.